So, we now continue our discussions from the previous lecture on IoT networking and the different issues governing it. So, when we are talking about building IoT networks, there are few things that will have to be considered. So, in this lecture we will talk about these. So, for some of these requirements for IoT networks include coverage, high throughput, low latency, ultra reliability and high power efficiency. These are some of these requirements. So, you need to ensure that there is adequate coverage in terms of the deployment of these sensor nodes or these IoT nodes in the terrain of interest, and then ensuring that there is sufficient coverage in terms of sensing, in terms of communication throughout the territory of interest of where the IoT devices are deployed. So, that is coverage. The second thing is throughput. It is very important that the network supports high throughput, and that, so throughput essentially we are talking about the data rates, high data rates, ensuring that through the network, which is typically a lossy network, you have higher throughput, higher data rates that can be supported. Then low latency, and this is very important, latency means delay. You need to have an assurance that from the source to the receiver, intended receiver, the time that is spent is minimum time. So, low latency networks are very important, particularly because in most cases IoT networks, not in all cases, but in most cases IoT networks would have to support real time traffic, where the timeliness of the data, as we said previously in the previous lecture, is very important, and these packets, if they do not receive, if they are not received on time, then that data is not going to be useful for supporting the adequate quality of service of the network. The next one is reliability, ultra reliability in the face of lossiness, in the face of lot of interference, noise, etc. This is very important and is a challenging job. The next one is high power efficiency. We are talking about low powered nodes, low battery power, highly constrained, energy constrained environments. So, it is very essential to ensure that whatever solutions we are talking about from a networking point of view, or in fact from any point of view for IoT networks, IoT systems, these have to be highly power efficient. So, before we talk about any further detail, let us again go and talk about a sample implementation of IoT and IoT implementation. So, this is a very simple kind of example, a very simple rudimentary kind of example that I will give you. So, let us say that we are talking about these different IoT nodes. These IoT nodes will, these are sort of like different sensors. So, we are talking about sensor nodes or sensor modes and so on. So, these IoT devices will have different components such as the radio interface, the processor, the sensor, and few other components could also be there. So, these IoT devices will collect the data. So, this data will be sent through the gateway, through maybe a proxy server, through the internet, some maybe web socket might be there, to maybe some cloud, some cloud storage, some cloud for processing. right. So, this is cloud, and then so the cloud will do storage, processing, etc., and at the cloud there could be different types of analytics that could be executed. Based on the analytics, there could be some actuation, and this actuation is very important. So, as you can see over here, this is this entire a very rudimentary form of IoT implementation, where we started with these IoT sensor nodes, the sensor modes, till actuators, actuation using the actuators, and we have done a bunch of things over here, bunch of things including networking, processing, analytics and so on, right. So, we need to understand this thing in sufficient detail, and this this kind of thing is typically done in student projects, typically hardware hackathons and all these things. It is basically the basic architecture that the students use is this thing. Okay. So, let us now go forward. So, let us talk about some of the solutions, one of which is the MQTT protocol. MQTT, the full form is Message Queue Telemetry Transport, which was introduced by IBM and standardized by OSS in 2013. MQTT is based on the concept of publish subscribe. This is the key thing over here in MQTT, and this works on top of the existing TCP IP, the way MQTT has been designed to work, right. So, publish subscribe, but this the way MQTT works is basically to work on top of TCP IP, but you could have a different variant of MQTT where TCP IP framework may not be used, right. You could come up with something else. So, the advantages of MQTT is that a publish subscribe framework has been proposed, which is very suitable for IoT, because IoT devices typically would be publishing data, sensing data, publishing the data, and you need to take help of the subscribers, the clients, etc., who will try to pull the data out of the published data that is buffered somewhere in some agent. So, this kind of architecture is suitable for IoT, and it has the advantage of being reliable, lightweight and cost effective. So, this is an example of how the MQTT publish subscribe framework works. So, look at this particular picture. So, we have the MQTT client, which is the publisher on one hand. So, this publisher basically will publish different sensed data such as temperature, humidity, etc., and this data will be published in the MQTT broker. This will be published in the MQTT broker. So, MQTT broker, which is a server, basically stores this data. Now, different clients like these would subscribe to, depending on their interests, subscribe to this data, and that based on the subscription, this MQTT broker, the server, is going to respond with the published information. So, this is overall based on the publish subscribe model, and this is how this MQTT protocol essentially works. Now, let us look at few more concepts before we talk about few other things. In MQTT, we are talking about different components, MQTT components. What are these components? We are talking about publishers, we are talking about subscribers, and then we are talking about these brokers. Okay. These publishers are typically these lightweight sensors. The subscribers are the applications which are interested in sensor data, and these brokers basically would help to connect the subscribers with the publishers. So, this is how it is going to work. Now, let us look at, in this kind of backdrop, what are the different models for this connectivity. So, for this MQTT provides different methods. These are the MQTT methods. Some of these methods that are used in MQTT are connect, disconnect, subscribe, unsubscribe, and publish. So, these are some of these methods that are used. So, essentially what will happen, using these methods, we will have some kind of these publisher which are like different IoT sensors like temperature sensor, etc. These will send the data to the broker which has this queue where the data will be queued at the broker, and then based on the subscription from clients, client 1, client 2, etc., the data are going to be sent. So, these could be laptops, PDAs, mobile phones, etc. Let us look further ahead. So, we need to talk about QoS now, because without QoS we cannot think of IoT. IoT is about services, quality of service is very important. So, for QoS of MQTT protocol, there are different transactions that will have to be taken into consideration. The first transaction is basically between the publishing client and the MQTT server, and the second transaction is between the MQTT server and the subscribing client. So, the client on each transaction sets the desired level of QoS. For the first transaction, the publishing client sets the QoS level. For the second transaction, however, unlike before, the client subscriber sets the QoS level. In the first one, publisher sets the QoS level, and in the second one the subscriber sets the QoS level. So, there are different levels of QoS. The first one is the QoS 0, which is about ensuring at most once delivery. So, this is kind of a best effort and unacknowledged data service, and here the publisher transmits the message one time to the server and the server transmits it one time to the subscriber. So, there is basically no scope for retry. QoS 1 on the other hand talks about at least once delivery, where retry is performed until the acknowledgement of the message is received. QoS 2 is further different. It is about exactly once delivery and ensuring that, and the retry over here is performed until the message is delivered exactly once. So, this is how this MQTT protocol works. So, let us now look at the COAP protocol. COAP is kind of an application layer protocol. It is kind of even more specifically it ensures sessions, so session protocol etc. So, COAP is is a protocol which helps ensure running different APIs, different applications at different applications in IoT. So, let us look at this COAP protocol in further detail. So, COAP, the full form of COAP is Constrained Application Protocol, which was designed by IETF core, which we have looked into before. The full form of core, if you recall, is Constrained Restful Environment. So, this particular working group has come up with this code to enable applications with lightweight interface to be run in place of HTTP. So, it is a RESTful service which is equivalent of the HTTP. So, instead of HTTP you run core. So, core basically works on top of UDP in the transport layer. So, this there is a protocol which is called the Datagram Transport Layer Security Protocol for securing the transport layer. So, this protocol is basically used along with COAP. So, COAP defines 4 types of messages. One is the conformable message, second is the non-conformable message, RST is the reset message, then you have the acknowledgement, the ACK message. For conformable type message, the recipient must explicitly either acknowledge or reject the message. So, some confirmation, right, some confirmation has to be received. And in case of non-conformable type message, the recipient sends the reset message if it cannot process the message. So, it utilizes different messages such as get, put, observe, push, delete etc., like the MQTT ones that I mentioned earlier. Similarly, here also you have support of all these different message types like get, put, observe, push and delete. So, so together basically these messages are used in order to perform different things such as IP multicast etc., in M2M communication for IoT. So, that is in brief, and I do not need to talk about it in further detail, but if anybody is interested, there are a lot of things about using how each of these messages, the get etc., that I talked about just now, how this could be done, what is the timeline diagram etc. So, all these things are available if you want to if you have further interest to dig into this particular protocol. But from an expository point of view, I think this kind of information whatever I have provided to you is sufficient. From another point of view, there is another protocol which is called the XMPP protocol, the full form of which is Extensible Messaging and Presence Protocol, which is again based on publish subscribe model that we talked about in the context of what? In the context of MQTT, right. So, the communication protocol XMPP is based on XML and it uses DTLS, secure transport layer, at the bottom in the transport layer for transport layer security. So, this model is decentralized, that means there is no requirement for having a centralized server, and it has manifold advantages such as it supports interoperability between heterogeneous networks, heterogeneous devices, heterogeneous agents and so on. It supports extensibility, that means supporting privacy lists, multi-user chat, publish subscribe chat, status notifications etc. And it also talks about the advantage of having the advantage of flexibility, which is basically supporting customized markup language defined by different organizations according to their needs, because it is based on XML. So, that those are some of these very high level features of XMPP. Another one at a very high level we are going to talk about, just to briefly expose you, is the AMQP protocol. So, AMQP full form is Advanced Message Queuing Protocol. This is also based on the publish subscribe model like MQTT and XMPP, and it supports 2 types of framework. One is the point to point communication and the other one is multi point communication, and is typically used for applications such as financial applications, digital finance and so on. It uses token based mechanism for flow control, which ensures that there is no buffer overflow at the receiving end. So, flow control is all about that, and this basically is AMQP uses a token based mechanism, the details of which I am not going through, but at a very high level this is the kind of feature that is there with AMQP to ensure that there is minimal buffer overflow at the receiving end and the flow control is preserved. The message delivery guarantees are of different types using AMQP. One is at least once, that means offering guarantees in terms of message delivery, but these guarantees may do so multiple times. At most once, which is about ensuring that each message is delivered once or never, and exactly once, which talks about ensuring no message gets dropped and is delivered only once. IEEE 1888, this one is an energy efficient network control protocol, which defines a generalized data exchange protocol between the network components over IPv4 or IPv6. It talks about the use of universal resource identifiers and supports different applications for environmental monitoring, energy saving, central management systems and so on. Another protocol from a network point of view, these I am just touching upon, I am not going in further detail, because the first few I have gone through, others it is sufficient, I believe, if you just know what is there and overall what they do, these protocols. So, DDS RTPS, what is it? So, the full form of this thing is distributed data service, real time, publish and subscribe. Again we are talking about publish subscribe. So, as you can see, this kind of publish subscribe model, because of its inherent characteristics, are very much attractive for use in IoT networks, because of the way IoT networks work. So, these support publish subscribe framework on top of UDP transport layer protocol. So, it is a data centric binary protocol, and these data in this context are termed as topics. So, there are topics means like there are users which basically subscribe to a particular topic of interest, and the listeners basically listen to these. So, there is a single topic that may have multiple speakers of different priorities, and this supports enlisted QoS for data distribution in terms of data persistence, which already in a different context we have talked about, maintaining, ensuring delivery deadline, reliability, freshness of data, and these of each of these in a different protocol earlier in the context of IoT networks we have already specified them, and the same meanings also carry in this context as well. Applications such as military, industrial and healthcare monitoring are the ones that find this particular protocol to be of use. With this we come to an end of both the lectures on IoT networks. All these protocols that we have talked about are very much attractive for use with any kind of IoT applications, and IIoT and Industry 4.0 applications, these protocols are very attractive. So, let me also tell you one final thing before we end. So, when we talk about Industry 4.0, Industry 4.0, we are talking about one of the very key requirements is connected behavior, connectivity, connectedness. This connectedness property is core to Industry 4.0, and for this all these protocols, these publish subscribe based protocols that we have talked about in this lecture and the previous one, these will help you to build this kind of connected system, connected network and the behaviors content within it. With this we come to an end of this lecture. Thank you.